Continuing in 8.7, we're up to example 5. And sometimes they don't give you a function, and so this is what happens when you don't have a function. They're going to have to give you enough information to be able to get the y's without actually having an equation. So it says world oil production. You've got a table in your book, and the rate of oil production is given by the function R when the total amount of oil produced in billions of barrels over the time. Okay. Use the midpoint trapezoid rules to approximate the total oil production between 1992 and 2008. Okay, let me take a break here and get this table written out. Alright, so what we're going to do is we're going to start with t equals 0 would represent 1992, and t equals 16 will represent 2008. And we're trying to add all of these up. Now it says, does it tell us how many breaks to make? It does not. Okay. They're wanting us to do 4 subintervals. So what's going to happen is we've got a total of 16 years. If we do 4 subintervals, your change in t is going to be 4 years. So in order to do a midpoint on this, I've got to find the middle of each of these. So the middle between 0 and 4 would be 2, which would be this value right here. The next one would be at 6. So 92 is 0. I'm going to go to the 6th one now, which, let me write it out a little different. We're going to say delta t is 4. So we start at 0, then we have to add 4. So 0, 4, the next spot would be 8, the next spot would be 12, the next spot would be 16. The middles would be at the second one. This one would be at 6, this would be at 10, this would be at 14. Now over here, remember this was 0. So here is 2, 3, 4, 5. This guy is going to be 6. 7, 8, 9, 10 is going to be this one. 11, 12, 13, 14 is going to be this one. So those are the middles, because what we're actually doing is we're taking 4 chunks, 2, 3, 4. We're taking all the way to here, and that's the middle. And so on, all the way down the page. Okay, so if I do that, we have a width of a rectangle, or it's trapezoid, excuse me. Midpoint? And trapezoid. Oh, they got 2. I don't do 2. Okay. So the midpoint one is going to have 4 rectangles. What's going to be r at 2, the function was r, plus r at 6, plus r at 10, plus r at 14. And we have to times it by the thickness, and the thickness is 4. That's your delta t. And so you look in your chart and you get 21.5 plus 23.7 plus 24.8 plus 20, oops, that's a 2, 6.3, and the whole thing's times by 4, and your midpoint rectangles give you 385.2. Now, if you're going to use trapezoids, and they decided to use, oh, I see, okay, t of 4, remember that you have to use that 1/2. That's going to go to everybody. And then the height is 4. And remember, the book writes this one a little bit different than I do. So it's going to be, remember the formula is 1/2 the height times the sum of the 2 bases. So 1/2, the height again is 4, the sum of the 2 bases. Now, the first one counts once, so you want to find r of 0 plus 2 r at 4 plus 2 r at 6, not 4, 0, 4. Oh yes, the next one's going to be at 8, because I'm using the initial breakdowns. then 2 r at 12, and then finally the last one is just r at 16. So this gives me 2 times, and then I look these up, r at 0 is 22.3, r at 4 is also 22.3, but I have 2 of those, and then 23.7, and then 2 of 25.2s, and then a 27.5 for the last one. Oops, bracket. And when you add all of that together, you end up getting 384.4. They are reasonably close together. So the midpoint rule and the trapezoid rule, I would say the trapezoid rule is a little more accurate. You can double check it to see if it's going to work. You could, and they've got this little trick they have in the book for you that says if you add up the trapezoid and the midpoint and divide by 2, you should get double the trapezoid. So if you're looking for t of 16, then you would take the trapezoid at the middle point. Oh, I didn't say that real well, did I? The formula actually says the trapezoid at twice the number is equal to the trapezoid at half plus the midpoint at half over 2. And so they went in and looked those up, got those two numbers, added them together, divided it in half. So we have 384.8 plus 387, oops, that's an 87.8. Dividing that by 2, and they get the 386.3. I don't know that it helps you any, but there's a little trick there for it. The next thing we're going to talk about is Simpson's rule. Simpson's rule says, instead of drawing rectangles or trapezoids, let's draw parabola shapes. So if I'm looking at a curve, and I broke it into all these chunks, I would try to get a parabola that fits here, and I'm trying to figure out how I want to draw it, and a parabola that fits there, and a parabola for there, and a parabola for there, and a parabola, because parabolas would be better fits. Now, it turns out the formula for that is a little trickier. What happens is you are going to, and they're going to use Simpson, S of n. You're going to take the first starting point, and then you're going to go with 4 times the next place you stop's height, and then 2 times the next place you stop's height, and then back to 4, and it keeps alternating like this all the way out to 4 times the height of the second to last one, so n minus 1, plus the height of the last one. Oh, and they write this part at the end, and I don't like it at the end, so I'll put it in the beginning. Plus, here you have to have, and I can't fit it, delta x. I'm going to go like this. Right there is a delta x over 3. So remember, your delta x is b minus a over n. So this is going to turn into b minus a over 3n. And that formula has to go right in there. There is a stipulation on this. You have to have an even number of intervals for this to work, so n must be even. Oops. And if you have the trapezoid approximations, you could use a shortcut to it. And the shortcut is 4 trapezoid of 2n minus trapezoid at n divided by 3. And I'm not going to do it that way. I'm going to actually do it with the formula because it's easier on your brain. And so we'll do example 6 next.